Hello, everyone. How's it going? It's 2 minutes late right here, but no worries. I was actually checking out Jocelyn's stream just before this, which was Introduction to Streamlit, and I think that was pretty cool. Pretty cool. Okay, we'll wait for a couple of minutes for folks to join. Uh, Whoever has joined, hello and welcome. Welcome to part 3 of our building our own mini SQL database. Let me just set up some stuff right here. That I did. Okay, that is too rocking. I think this is good. Yep, pretty good. Okay, perfect. Hello. Uh, yeah. So as I was saying, welcome everyone. Welcome back, everyone. Whoever is joining for the second, I would say third time, and whoever is joining for the first time, hi. I am UT from MLH. I prefer to go by UT. My name is Utkarsh, and I am going. I'm doing this third session on building our own mini SQL database. So if you're new to this session, I'll give you a very quick overview. What we did was actually today we took a 4 hour session back to back, so 2 hours, 2 hours with just 10 minutes break in between, about learning SQL. Okay, we learned about SQL. We learned about what are SQL databases. We learned about different types of databases. Actually, yeah, we you know had an overview of what is SQL, no SQL, new SQL, in-memory databases, let's say time series databases, graph databases. Then we went on to this pretty amazing website called as SQLBolt right here, which we used to practice some real world SQL syntax, very basic ones. And then we actually went on to create our own database. Okay. And just to give you an overview, when we left the session last, after that, I have done like some updates on the README. So I can actually quickly, why do I have this here? I wonder. I can put it right here. I actually went on to add some stuff, and this is what we ended up with. We have created this particular folder structure where we are creating the storage.js, schema.js, query.js, some logging and testing our own database, and a sample output of what we have achieved so far. Okay, we have successfully achieved creating a table. Okay, creating actually kind of a database folder. In that, creating a table. Once the table creation is done, inserting data into the table. Okay, using this insert into queries. Then we have done like select statement where we can specify what do we want to select. So if we go back to the code, so selecting ID and name from users gives us two things. Or you can go for a wildcard, which is select star from users, where users is the name of the table, and it returns everything. Okay, so we have successfully created all that. A few things that we have actually done, like also written as homework, I would say, or something for you to practice on, is also there, which is this, like make it smart by checking what is missing in the query, or make it case insensitive. Okay, so into currently needs to be capitalized always, make it small. uh, in schema.js, actually, what is it, actually I think it's in query. Yeah, in query. Another homework that we're supposed to add and I forgot to add was to do colon homework is, so we added this piece of code to differentiate between text and numbers. What about booleans? Check for float and boolean. Okay, so for anyone who is feeling a bit overwhelmed, who's joining for the first time, and you're thinking, what is exactly going on? I have no idea. Uh, in that case, I would say what you need to do is get the code. So I will share the code, the repository, very quickly in the chat. So now you have the code. And to give you a very simple overview, what we are doing is building a SQL-like syntax database. Okay, so a database which is more like a JSON file structure, and we are writing some code so that when you use this database, this, I keep saying database, but when you use this file system, you write syntax which is more SQL like. Okay, example, in SQL syntax, to create a table you do something like this, to insert into the table you do something like this, to select data from the table you do something like this. Okay, and we are kind of trying to replicate that with JavaScript. Create a table, insert into the table, select from the table, and yeah, that is what we have done so far. And I hope that gives you a very quick overview that we are trying to imitate SQL syntax but work with JavaScript file system. uh, Work with file system using JavaScript. Okay, yeah, that makes much more sense. uh, okay, so that is a quick overview of what we have achieved so far, and you have the code anyways. Now, before we get into the session, please do register for this session. The link is in the chat. Hopefully, that would be helpful to you all. So, very quickly, please do register for the session. Helps you, helps me, helps MLH, right? Okay, now what are we going to achieve like next? What are we going to do next? Now, one of the things uh, that a SQL has is the where clause. Okay, now we are going to actually add the where clause parsing. But before we do that, let's first learn it what happens on a real SQL table. So I'm going to click on, like, hopefully you have completed SQLBolt till here. The link is in the chat. Hopefully you have completed it till here. Let's go on to the next one. And this is what we are talking about: queries with some constraints. Okay, so one of the constraints is constraints, or I would say a way to filter out results, is by using the where clause. You can also call it as a condition, let's say. Okay, so let's write some real SQL code, and then we'll try to replicate this in JavaScript. So here's a question, which is uh, find the movie with row ID of 6. Okay, so to do it very simply, what we want is this particular row. How can we return only this particular row? The way to do it would be to add where ID equals 6. Once I do that, I have kind of added this condition, and that passes this one, right? Uh, yeah, I hope that makes sense. What's next? The next one is find the movies released in years between 2000 and 2010. Now, this should be simple enough. And actually, we can kind of break it into multiple lines. Okay, this would still work. So select start from movies, uh, and we want to filter out on the years. So we can say where years, and now we want between 2000 and 2010, not 2006. Why did I say 2006? Sorry, between 2000 and 2010. So there are multiple ways to do it. You can always do like the way we did equal to for the previous task. Similarly, we can do year less, no, greater than 2000 and less than equal to 2010. But we can do it in more English syntax, which is writing between 2000 and 2010. As you can see, that is also exactly what the question was. So find the movies released in the years between 2000 and 2010, and that's what exactly we wrote. So SQL is very, from syntax perspective, it's very easy, kind of, or at least the beginning is very easy, I would say. It gets pretty weird pretty soon. Now the next question is find the movies not released in the years between this. And in this case, again, let's go with a not between, and that actually solves this one as well. And the next one is find the first 5 Pixar movies and their release year. Okay, so first 5 Pixar movies and their release years. Multiple ways to do it. Okay, multiple ways to do it. The easiest would be, I would say that the ID is less than where ID, remove the year, less than or equal to 5. Okay, or if you knew the year, you could also do like year less than equal to 2003. Multiple ways, right? So I think this was the easiest one. So this is how we learned about the where clause. So let's try and implement this in our JavaScript, in the JavaScript version of our select query, that is. So that's our insert into query. This is our select query. So you remember this const match equals query.match select from something something something. And now after this, we will add question mark colon where dot plus question mark. Okay, so I think this should do the trick. So we are saying that select, then name of the table, from table name, then open a bracket and wait for this where, and then you will have something else. Okay, so that's one way to understand it very quickly. Going to our columns, we had created the columns, we had created the table. Now we'll also create the condition. Okay, I think this should work. So condition is the third part of the match that would come in, and the data is still fine. If not data, then we'll of course log in some errors. Now the filtered data is where things will get a bit interesting. So we'll say for filtered data, we'll say that for some particular condition, if we'll say that if the condition exists, okay, in that case, data dot filter over like for each row, const condition function equals new function. We actually discussed in detail about this new function, okay, and what it could do. I'll have to search where we wrote it. Uh, but anyways, the new function, and we will actually do what? We'll say over a row return, and then we'll do condition dot replace hmm, place our word with row dot $1. So the first part of it, I think this should do the trick. So const filter data condition is data dot filter, created a new condition function, and we'll say return condition function row else return data. Okay, perfect. There we go. And now we will do a const result of filter data dot map, which should be fine. Return row should be fine. Uh, const selected row should be fine. Columns dot for each should be fine. Return selected row should be fine, and this should be fine. Actually, we can like switch this over. We'll log that it is successful first, and then print the result. Okay, let's test it out. I'm going to copy over the test select v1 and create a test select v2, where we'll say select id comma name from users, where id equals 4. And in the second case, we'll say select start from users, where id less than 3. Okay, let's see if this works out. I'm going to clear the terminal and run the test, and there we go. There is at least one error in this. Let's do it one by one. Going to comment this one out, the second one. Unexpected number. What about name? Okay, it's not exactly working the way I expected it to work. We'll have to sanitize this a bit. Interesting. I would have thought that should work out. So ID, comma name. Actually select star. Let's not focus on one thing. Select start from users where name equals this thing. What am I missing? Hmm, give me 1 second to think. Or we can skip this, move ahead, and come back to this later. Okay, I think we can skip this for now because I would have thought that this would work out, but unfortunately it doesn't, which is very interesting. Hmm, okay. Uh, Mostly, I think I need to basically work on this condition function a bit to kind of understand how exactly can I replace those things. Okay, for now, I am going to go back, actually leave this be for now, and just add a note saying condition not working. Okay, so I think this should be a good place for to stop the query part. We learned about where clause exactly, but the implementation in JavaScript is still a bit tricky and probably requires me to work on it a bit more. I would have thought that this would work out perfectly as is. Unfortunately, that doesn't seem to be the case. So I'm going to skip this over for now so that we are still on time for completing the rest of the module. So the next one would be uh, from the concepts perspective, actually, is, let's say, indexing. Okay, now this one is going to be interesting. So what are indexes? What exactly is this index? So index is, you can think of it as a data structure to optimize the query performance. Now, why does indexing matter? It basically speeds up the searches and it reduces the scan times for large data sets. And one of the ways, or how SQLite handles indexing, is by using something called as B trees. Okay, B trees. Uh, if I have to go into a technicality, in the technical terms, a B tree is a self-balancing, multi-way or multi-branch search tree data structure that maintains sorted data, okay, and allows for efficient insertion, deletion, search operations. Now, specifically, they are used in databases, uh, and I would say even for file systems. When you do a command F and then you start searching for something, it has to go and search for whatever you are typing, right? So I would say that kind of uses your B trees, uh, or something very similar, to ensure that it is searched through very quickly. Okay, and if I have to give an example of explaining it in a very simple way, so you can imagine a B tree is like a very big shelf. Okay, and the way this shelf works is, if you have to find a book called as G, okay, the alphabet G, what you would do is that you'd start from the top of the shelf. Now, at the top of the shelf, you actually have only like four books or five books, let's say. You have the book A, you have the book E, you have the book I, you have the book M, you have the book Q. Okay. So books A, E, I, M, Q. Okay. These are the books that you have. Now you have to search for G. You know, this is in alphabetical order. So you kind of know that my book will not be between A and E, it would be between E and I. Okay. If it is between E and I, there would be a door. Okay, you can think of, now you will come to the next shelf, and you would only focus on the row or the column, I would say. Okay, you can say that you will only focus on the columns that are between E and I. Everything else you will discard. So you've kind of reduced your time to search through the whole database by specifying that I don't have to search between A and E, and I and M and Q and Z. Okay, I only have to search between E and I. Now you come to E and I, and that has that inside that you find two things. You have the books that start with F and the books that start with G. Okay, and since you wanted to find the book that is starts with G or G, uh, in general, you would just directly go to G, and you have reached there in, I would say, one, two, three steps. Okay, so this works because the data is already organized and sorted. Okay, alphabetically. Now, in terms of database, what this means is that the data would be mostly sorted by IDs. Okay, unique IDs, which are, if possible, they are incremental in nature. So if you have to find something between 1 and 10, you can discard anything after 10 and then focus only on the 1 to 10. I hope that gives you kind of an idea, okay, of how B trees exactly, not exactly, but how B trees work. And now, if you take the whole database, okay, it's very difficult. Like in the example of our books, if I say that you have, like, on the main or the top shelf, okay, you started from the top shelf had A, E, I, M, R, Q. Okay, A, E, I, M, Q. So those are just the letters and not exactly the books. Okay, so with A, you will have like hundreds of books. You have hundreds of books with that start with the title, that start with the name E. Have E in the title, start with the title E. Okay, you have hundreds of books that start with I. But what we said was that we will create a subset of all the books and find out the commonality, and tell people to focus on, like, in this particular shelf are all the books that start with A. So this A, E, I, M, and Q, this was kind of an index, you can say. So an index essentially is kind of a subset of all the data that you have. Okay, and you create index on something. So SQLite, the SQL syntax actually is, why is everything okay? The SQL syntax for doing so is create index and then the index name on the table name, so which is would be like, let's say, users, and let's say on the column, so on the name column. Okay, so create index, whatever is the index name on the users table with the column name is, yeah, is how a syntax would look like. Something very similar. I think this is exactly the syntax. So yeah, so when you create an index on something, you kind of say that I want to take this whole thing out, or not even out. I want to create a copy of this which is easily searchable or quickly searchable. Now, the implementation that we are going to do is not going to use the syntax yet. It's not going to use this SQL syntax yet. And frankly, it's very difficult to exactly test that is our indexing working actually. Okay, because indexing would require ton of data. If you have loads of data, you have like 10,000 rows of data, then it would actually make a difference visually of what, if you're searching on an index versus if you're searching on non-index. So I am just going to say that let's try and create something for it, and we'll worry about everything else later. So going to delete the database so that we can start fresh. And now inside our lib folder, I'm going to create a indexing.js. And following our tradition, we'll say lib/indexing.js. Then we will name this at module indexing at description implements indexing and optimized lookups. Okay. Yeah. We'll say, actually, we'll import it later. Okay. Let's start writing. So the first one, the first function that we are going to create is called, will be called create index. So it creates an index on a specific column of a table. It will take the first param, which is of type string, which would be table name. So this time I'm not going for the query yet. Depending on the time that we have tomorrow, or today, depending on which time zone you are in, we'll add the syntax. Okay, the next one would be string, and it would be the column, and this would be the column to index. Okay, or column name, you can say. Let's create this function. Export function create index takes in two things. It will take in the table name and it would take in the column, and we'll say const data path equals get table file path, table name, and the file type. In this case, oh, need to import this. Weird. Import from dot slash storage dot js, and we want to import the get table file path. Okay, yeah, there we go. It takes in the table name, which is of type string, and the file type, which is of type string. It could be either schema or data. In our case, it's going to be data, because we want to create the index on a data, right? And const index path would be get table file path. It would take in the table name, and then it needs to take in the second type, which is the file type. And actually this would be something completely different. This would actually be the column dot index. Okay, that's how we are going to name it. So now the next step would be to const data equals read JSON data path. Okay, so read the file that, or the table which we are supposed to create an index on. That's what we are doing. And if that table does not exist, let's do an early return saying that log error and table double inverted table name does not exist. And we'll copy paste this again, and instead of log error we will do a throw new error. Okay, so that you can actually see an error. Now for index, okay, what are we going to do for the index? We'll say const index initially start with an empty object. Then we'll do a data dot for each, and we'll say row comma index or I. Const key is basically the row of the particular column that the user has asked for. Okay, so if you have asked for the column name, let's say, oh, I've deleted everything, but let's see what columns did we have. We will have ID, name, age, student. Okay, let's say you have asked to create an index on age. Okay, so this would be the row of age. Okay, and whatever is the key, like that would be assigned to the key. If not index of key, if this does not exist, then in that case index of key would be an empty array, and then we will push for that particular key, like, yeah, push the value inside that particular key. And we'll do a write JSON, which would take in the file path, which in this case would be index path, and the data, which would actually be index. And then we'll say a log success index brackets index created on whatever is the column of table table. Okay, I think this should be good enough. And since it is exported, let's go to our test DB and let's create something, okay, which will make it much more easy to understand, right? So let's do function test create index underscore v1. We'll do a try. Since we have not written a query, we are not going to do this const query or something. We'll directly call the create index we will say the table name is going to be users table, and the column name is going to be, let's say, name. Okay, and let's say catch error. Once this is done, we will do what we have been doing, which is copy over this logger thing, test magenta console info, and this is create index test past, and just okay, copy over the error one, come on here and paste it, and oh, create index test failed. Perfect. And let's call this function. Let me increase the height of the terminal so that it's visible. Hit enter, and there we go. Index created on name of table users. Actually, we can call it on column space column. Okay, now if I run it, it gives you this answer of index created on column name of table users. And what happens inside our database, we now have a new JSON file, which is the table name dot column name dot index dot JSON. And if I go inside that, all it has is the name, the keys. Okay, so, or I would say the name becomes the key. And why is that useful? How is this fast? So if you dive deep into JavaScript object, or if on a Python dictionary, you would find that in a dictionary, searching for key takes, I think, O of one time. Okay, it's quick, it's instant, right? Is it that one, or insertion takes O of one? I'm confused now. So let's actually Google this together. Okay, O of n. Now this is confusing. Pretty sure it was O of 1 for something. It could be either getting the value. It's a time complexity O of 1 when I get a value from an object by a key in JavaScript. Okay, let's say O of n. Still very quick. Okay. So I would say it is. This is again. What? Let's see what people on Reddit say. The lookup is always O of 1, but the actual performance depends on the underlying memory representation. Okay, so you can get the value quickly by O of one time, technically, I would say. And this is what I remembered as well. So the reason why we create this whole thing is just so that we can, the index is basically now going to be the become a key. Okay, so it will, when you have to search for it, and if you have thousands of it, the performance is usually better on the key. So you can find the key the value is actually the index of it, or the id index of it in the array. Okay, so in the array, the value of the this users.name.index.json is actually whatever position it is on. Okay, so when you have to search for, like, let's say mlh, it would first come and search in the index, and it would go like, okay, I found mlh quickly. It would be supposedly o of near to about o of 1, and it would then check, like, it would instantly know that it is on the fourth position in our users data. Then it would go into this array and pick out whatever is on the fourth position and return it to you. Okay, so that is the overall idea of indexes, that you specifically take them out, store it somewhere, so that finding the index is quicker, and then getting the whole data would be comparatively much faster. Okay, because you don't have to then loop over this whole array and then specifically search where does the name match mlh. Okay, you'll search in the name index and then come back and search in the original data. Now this might sound good, and you might have a question that, well, then let's create index for everything. Problem is storage, right? If you create index on every single column, you're kind of duplicating every single data, which does not make sense. So you should always create index only on the required fields. Okay, only when something is actually, or you think that there is something which is more frequent to use, or people are querying for something much more frequently, that is when you should add an index for it. Now in case, like, let's say gmail, uh, gmail will add an index on the email address. Why? Because that makes much more sense, because email address are supposed to be kind of not supposed to be, they are unique. Okay, email address are going to be unique for a particular email provider. So for gmail, the email address that I have is going to be unique, and my name, my first name and last name, my age might not be as unique, but email address is going to be. So an index on email address would be like something very quick to search for Google comparatively. Then getting my name and, yeah, first name, last name, age from another table then would be much more easier and faster. Okay. And also one quick thing, in the B trees that we talked about, the B stands for balanced, not binary. Okay. And there is a very nice article on understanding B trees on SQLite tutorial.net. The link is in the chat for that. So there you go. Okay, now what else can we create an index on? Well, we can create it on multiple things, I would say. Uh, I think the name makes sense. What else would make sense? What about age repeated? Okay, let's also test that out quickly. Uh, insert query 6, insert into this, and the name is GHW, and the age is 10, and this is false. Okay, and let me also do an insert of 6, clear this out, and users on the age. Okay, so now it says that index created on column age. Let's go and check the index. So for age 10, now there is an array of two numbers. There is 4 and 5. So this basically says that if you actually search for all the, like, if you want the details of all the users whose age is 10, it will come into this index of age. It will search where is 10, find it quickly, because, well, O of 1, or I would say near about, let's say O of n. Okay, it will know the rows that it has to then go and get the data from, go back to our users data.json, and go for directly index 4 and index 5, okay, of the array, and pick out that data, supposedly much more faster. And it would return me two rows in this case. Okay, it would return me this and this. So that was about, if you have something of a duplicate and you're creating an index on that, in that case you will end up with like multiple results or multiple in IDs in the array, not IDs, multiple indexes in the array. Okay, so that was about creating an index. Let's add the next bit, which would be actually searching through an index, right? So mm, yeah, let's search with index is what we'll write next. So searches for rows in a table using an index. Now this would take in multiple params. Also, for the time being, just so that you can focus solely on screen, I'll go away. So string table name, this would be name of the table. It would take in another param, which would be string column, and this would be column to search. And then param, this could be either a string or a number, at least for the time being. Later on could be boolean as well. Value, and this would be value to search for. And what it would do is it would returns an array of object, and this would be the matching rows. Okay, so whatever I told you verbally is what we are actually going to code. So search with index takes in table name, takes in column, takes in value. Okay, yeah, I think so. This should be good. Const data path equals get table file path, table name, and data. Also, meanwhile, if you have any questions, feel free to put them in the chat. Okay, get table file path, table name, and how have we stored the index? It is in the format dot column dot index. Then we will do const data equals read JSON, because everything is stored as a JSON from the data path. Okay, and our very basic, very usual, if no data, then log error saying table name does not exist, and we would do a throw new error, and inside this we'll copy paste whatever we have here so that we can actually see an error. Const index is read JSON, wrong brackets, and this time you'd read the index path, right? And if, let's say, no index, basically you don't have that index file created, in that case we will say log error not table, actually this would be index on column, this particular column does not exist for table name. Okay, and just to copy paste this because I'm so lazy. Perfect. So if no index, then we'll throw this new error. And what next? Now const positions equals index of the value. Okay, so whatever is the value, in this case the value to search for, we are going to say that go, like, from the index path, take that particular value, like let's say Alice. Okay, so index of Alice would give me the positions, and if no positions, so if the array is for some reason empty somehow, then we will say log error no matching rows found for dollar value. So we'll say value colon dollar value. Let's put it in inverted commas in table dollar table name. Okay, and I'll put this in inverted commas as well. And because I'm lazy. Perfect. And if you have found it, then we'll do const rows is equals positions dot map, because it is definitely an array. We can say for each position return the data at that particular position. Okay, and then we can do a log info, because we have not used it actually. So let's use log info. Let's make it worth its while. Found matching rows for dollar value in table dollar table name, and at the same time let's print those rows. And we'll say return rows. Okay, I think this should be good enough. Now let's add some test for this. How do we test this? So let's do a function test search. What did we call it? Search with index. Okay. Search with index underscore v1. And again, since we have not, there's no syntax for it. Okay. So I'm going to say search with index. What all it takes? It takes the table name, which is a type string. So users. Then it takes in the column to search for. Now, what did we create a index on? We created an index on name and age. So I'm going to go for name first, and I'm going to say that the name is going to be uh, John. I don't really remember if there was a John in this, so we'll know that for sure right now once we get either an error or a success. Going to copy this one, going to paste it and say instead of search index, test passed. And if there is an error, going to copy paste this one and say search index test field. Okay, perfect. Clear this out. Also need to call this function. Let's hit run, and it says found matching rows for John in table users, and there you go. Okay, it found it where it found it. Now, about the answer of whether it was quick or not is kind of debatable. Okay, because there's just too less data to actually know that accurately. But let's just say, what about Paris? Okay, search with index for the name Paris, and it says search index test failed, no matching rows found for this. Okay, so let's go back to John. What else did we create an index on? We created an index on age, and the value that I want is going to be 10. If I run this, it returns me found matching rows for 10 in table users, and it returns me two things. For which somehow when I created it, it had the same ID, which is bad idea. IDs are supposed to be unique. Probably in very near future, we'll run, we'll fix this, okay, to make it unique. But if not, I can do it after all my sessions and push it on GitHub. Okay. I did that last time. It took me a week to actually complete the whole app that we were building. But once done, it was on GitHub. So if you want to revisit our React Native app building, feel free to go back. The code for it is actually on GitHub. If I go, just taking a quick detour, our MLH reminders app was there. Color palette generator is what I think it was this one. Yeah, MLS reminders app. Yep, 3 weeks ago. So we actually added gesture swipe, which I completed a bit after the end of GHW. Uh, but yeah, I reached there. I reached there maybe sometime later, but I do reach there. Okay, what about uh, oh, not create index. For the search index, I want to search on the ID, and the value that I want to search for is 103. Okay, what happens in this case? It gives an error because the index on column ID does not exist for table users. Now, when that happens, we wouldn't want to actually give an error. We would ideally want to then fall back to searching for this data in the data table. Okay, so in the users.data.json, we would ideally want to search it, but that's something that I'm not implementing right now. Let's add that as a to do slash homework. Okay. So instead of error, search through the table data if index does not exist on that particular column that you are trying to search through. Okay. So maybe that's something that we could implement. I'm adding like lots of to-dos, which would make our database actually more robust in future. For now, let me see if every test runs properly. Yes, everything runs properly and everything is kind of fixed, except for anything that we added as a to-do. Okay. So I think this is the good point to actually push everything. So I'm going to do a git add, git commit dash m, and this is a feature. And what did we do? We added indexing.js, right? Yeah. And let me do a git push. Perfect. Okay, there we go. 6 commits, and the link is in the chat. Okay. Okay, what next? So we have added the indexing and searching through index. I also shared a link of uh, yeah, more details on indexing. Okay. The next concept, the sixth concept for today, is going to be backups and restore. Okay. Now, what, like, let's talk about the importance of backups. Let me come back on screen for this because I'm going to use a lot of hand gestures. So, backups. Now, backups are important, right? Why? Because ideally, if I have to say it out as basic as it gets, is that it is for preventing the loss of data due to any accidental deletion or any memory corruption or something. Okay, so loads of instances. I'm pretty sure you might, or you all might remember. If not, then there have been instances where, like, I think there was one very recently for HBO, I think, uh, that an intern actually accidentally sent out a test message to in production. Okay, in production, being like us users, we received a test message notification, uh, and that's funny if you think about it. And from a learning perspective, you now know that okay, it's fine to learn. But similarly, I remember reading an instance of someone actually deleting a production database accidentally. Okay. And that kind of halted every work. But luckily, they had a database backup, or like from an hour ago. So they went back and restored or copied over the data that they had in the database, which was backed up like an hour ago, into the original prod database. So these things happen. Okay, things happen, life happens, things happen. And to prevent this loss or corruption, we want to create backups. So if you remember, when we created the git ignore, we are ignoring any data inside the database folder. There's also this backup folder that we are ignoring, because that's where we will create our backups. Now, how does SQLite back it up? So there is a command called as vacuum into, okay, which creates a safe copy of all the data. And when I say all a safe copy of data, it basically copies the .db files. Okay, uh, all the binary data that is inside it, it copies it over into in whichever location or whichever file path you tell it. Now, the challenges that come with database backups is that if your database is huge, okay, and I mean like you have not backed it up for like 5 years, and every day you have like at least 10,000 people, uh, or 10,000 rows of data, okay, not people, 10,000 rows of data coming in, that is a tremendous amount of data. And I mean, not that much, but let's say I think that's still a lot. Okay, definitely not easy to count. Every day 10,000 is also a very large number. I think I'm being too optimistic here, but let's say you had, like, in a hypothetical world, you had that amount of uh, that amount of data to back up. It's going to take, I don't know, maybe a week to actually back it up, provided that none of your computers fail. You have, like, I don't know, 128 gigabytes of RAM and stuff, uh, and you have like at least 10 Gbps connection. I think that's the only way you can copy it over to a remote location very quickly. And uh, yeah, that is a very big challenge for backing up large database. The second thing is synchronization in live system. Okay, so what I mean here is that, supposing that the database backup starts at some point, and there are users who are actually trying to hit your live database, copying and, like, the copying is more of a read operation in itself, reading and writing to somewhere else. A user is trying to access your database for some whatever reason, that's also trying to read, and you're doing two things simultaneously. Two things is even still fine, but one of them is a very heavy operation, remember. Okay, copying over is very heavy operation, and it takes in like all CPU resources, kind of. So in that case, your system becomes slow. So even that is, and then maybe someone added a new row, but it would take time to reflect because there is a copy that is going on, which has kind of slowed down the system. So synchronizing becomes a bit of a problem, okay, sometimes. And there is a very good blog about backing up. Actually, I have two things. So there's this one nice blog that I found when I was like trying to learn about what are the backup strategies for SQLite in production. Okay, for people who use SQLite in production, uh, what do you do? How do you do it? What's like, what are your suggestions, solutions? So this is one very good blog I found, about which also uses tells that there is a SQLite has an API for this, which is really good, which is vacuum into. There's also a Stack Overflow answer, which was kind of like sufficient for a very quick go through. So there you go. Okay. So now in our case, what are we going to do? So in our case, we are going to create a backup.js file. And what do we want to do? We want to create a function which will be like backup database, which will read the database path. Okay, it will read where is the database, and then it will create a copy of it wherever you want it to. Okay, yeah, I think that makes much sense, right? You tell it that I want to create a copy of this whole database in some folder, some path, some folder, something, and it will do that. Okay, so yeah, so these are the this is or these are this is this these are the two functions, no, one function of backing up the database that we want to do. And then the other one would be restoring the database, which is copying over from your the backup to your main database. Okay. Yeah. So these are two functions that we will write. Excuse me for a sec. Okay, I'm back. Sorry, had a cough. uh, okay, so without wasting any further time, let's go into our lib and let's create a backup.js. Okay. Now, following our tradition, this would be lib slash backup.js, and the module is backup, and the description. Next line, next line, next line. Handles database backup and restore functionality. Okay, and the first function would be backs up, backups up, no, backs up the entire database folder to another specified directory. It takes in a single param, which is going to be a string, which is going to be backup path, and this would basically be the directory to save the backup. Let's write a function. Oh, also you can focus on the screen. Export function backup database. It will take in the backup path. If not, fs needs to be imported. So let's do that. Import fs from fs. So if not fs dot exist synchronously the backup path, fs dot mkdir sync, okay, or make directory synchronously the backup path, and then we'll say recursive is true because we want to actually copy over or create if we have to, like you provide a path which is like nested, then in that case, yeah, just keep on creating the files and folders. Sorry, a cough again. Next is const, I would say files is fs dot read sync, okay, read directory synchronously, and we actually want to read it from the database path. Do you remember the database path? This was something that we had kind of added here. We could actually take it out and save it in constants or something, but for the time being, I think this is good. So in here, we have written that either read the path from this env file, or if you don't want to, then in that case, just create it in the current folder /database. Okay. Okay. Next is files dot for each file const source is path dot join, and for the path we need to import it from path. So path dot join the database path with the file. And why will this have files? Because, well, inside the database path, which is this database directory, there are 1, 2, 3, 4 files right now. Okay. So for each file, join the root database path and then plus the file. Okay. That's what we are doing. And const destination is path dot join the backup path that comes from here with the file. And now we'll say fs.copy file synchronously source comma destination. So from the source over to destination. So simple, right? And once done, just do a log success saying database backup completed successfully. Too excited. Available at backup path. Mm, okay, I think we can test this. Let's create another function. Well, we'll call it test backup database. Yep. So test backup database underscore v1. We'll do a try catch as always. We'll call in the backup database function, and the path for the time being, let's say that we want to create it on the root. Okay, so we are just doing backup, and let's do a successful test, and this would be backup test passed. And copy paste it right below, but in this case this would be console.error, and this would be failed comma error. Okay, and let's call the test backup database v1, clear this, shut all of them except for my test for the time being. And shall I move this to it's already at the bottom on the right hand side so that it's much bigger to see, like longer in the sense. And let's run this. Okay, there we go. Database backup completed successfully, available at backup, which does not really make sense, but as you can see there's a folder created backup and it has everything that database had. Okay, so what if I change the path to be dot slash uh, lib/backup. Let me delete this one. Clear it, and let's run all our tests again. So it's done. And now if I go inside lib, there is a backup folder. Okay. So now you can kind of this just going about kind of proves that we can create a backup anywhere. Okay. I just need to rename this. Instead of backups, it would be backup.js because we have not exactly it doesn't have a plural. It doesn't need to have a plural. And we are using it here, which was backup.js. Okay. Thanks to VS Code, it works. And yep, everything works fine. But I don't want it to store it inside the lib. So I'm going to store it in okay, perfect. Okay, the next one would actually be restoring. Okay, so going back to our backup.js, let's write a function to restore the data from somewhere. Okay, so restores the database from a backup directory. It takes in one param, which is the backup path. The directory containing the backup files. And we'll say export function restore database backup path. Okay, so restore database takes in a backup path which is of type string, and step one is to actually check if not fs dot exists synchronously this backup path. If this does not exist, then just print an error saying, oh, this needs to be a dot. Excuse me. Backup directory does not exist. Okay. And throw new error with the same message actually. Next would be const files is fs dot read directory synchronously, reader synchronously the backup path from the backup path. Okay, not the backup path, from the backup path. And it will have multiple files. So for each, so they even if there's one file, for each will work. For each file, const source is equal to path dot join the backup path with the file name, and const destination is equal to path dot join the database path, the original database path, and with the file name. And then we'll say fs dot copy file synchronously from the source to destination. Okay, and we'll say log success database restored from whatever is the backup path to whatever is the database path successfully. And I'm so happy that I use exclamation marks there. And the way to test it would be if I delete the database, okay, and wait, there is an error. Seems okay, this wasn't needed. Yeah, uh, I've deleted the database. I'm not going to run the backup or any other thing. So I'm going to comment all of this out and we'll create a new function which would be called as test restore database v1. And inside this we'll say a try catch, and inside the try we'll say restore database from which path, from the, so whatever path we have written here is the path that I'm going to copy over. Okay, and if that passes, then logger dot print back restore db test pass successfully, else uh, print the error and restore db test failed with this particular error. Okay, and I'm only going to call this particular function so that we know that for sure that this works. Okay, and let's see if we get any errors. Going to clear everything and run the test, and directory database directory created dot slash database. Wait, who's creating it? Oh, yeah, we had to create it, right? Yeah, right. What am I doing? So if I run this, so first it creates the folder, then it copies over everything from backup to database, and then restore database successfully passed. And there we go. So I only had the backup. It created the database actually, the database folder, and copied over everything. Let's see if it has everything. Well, it should. It's not that big of a thing, but okay. Yep, it exists, right? What if I delete both of them? Well, that's very obvious what's going to happen, but let's just test it. I deleted the backup, I deleted the database, and now I'm trying to restore it. And it says, okay, we have created a database folder, but to copy over anything does not exist actually, right? Okay, so I think this is good enough. Let me just uncomment all of these. Uh, Run everything. Everything should pass, ideally. Yep. Okay, I think that is good enough. And I'm going to push this back to bottom. And I think this is a good time to push all of the code that we wrote. Uh, any questions so far, anyone? I think it's pretty late for me as well as you all. Uh, it's like 12:37 a.m. for me. Uh, in India, it would be around what, uh, 4 or 5 a.m. Somewhere in between. Uh, in US, I think depending on time zone, it might be evening for some of you. Might be l- earlier or later. I'm not sure. Anyways, uh, you can still find all the videos on YouTube of Major League Hacking channel, MLH channel. So you can feel free to watch it later, right? Git add, git commit. We added backup.js and git push, and that is it. Okay. So backup.js is done. Also, at some point, I should update the README. I'll do that towards the end. Now, for the last part of today's session is locks. Okay. And I think this is the most amount of, like, this one thing where most amount of code needs to be written. But I'll try to explain it. So locks.js, uh, and it is plural. Okay. Just for your reference, it is going to be plural because lock is not a single thing. You have implementation of, like, you'll have multiple locks that exist at different point of time. Okay. Now, what are locks? Okay, let's talk about that first. And let me come back on screen for this. Okay, so locks is a very interesting concept. You remember the whole acid property that we were talking about, which is atomicity, consistency, something and something. Wait, I don't remember the full form always. Atomicity, consistency, isolation, durability. Yeah. So the atomicity and the consistency. Okay. Specifically, I would say this, like, for this, uh, you have locks. Okay. So when concurrent concurrent transactions happen, which is like two things trying to happen at the same time, at that instance is when the locks become necessary. It is to prevent race conditions. What is a race condition? Again, something like two things trying to happen at once, two things trying to update a row. Like, if I have uh, my GitHub account logged in two different devices, my desktop, my laptop. I'm logged in both of them. I'm trying to change password via both. And for some reason, I'm able to do it instantly. Okay. A hypothetical scenario that I'm able to do it instantly. And from one machine, I'm setting the password 1234. Bad idea. Don't do that ever. But somehow, I'm able to. And in from other machine, I'm trying to set the password as ABCD. And by God's grace, when I hit enter, it is at exact same time, like till milliseconds. Okay. And GitHub only tracks till, like, let's say milliseconds. So what happens in that case? Okay. Two things trying to uh, access this one particular row in a table and updating the password at the same instance. So in this case, concurrent transactions are trying to happen. And what you would do is, what GitHub would do it in this case is, it would lock the data. Okay, it will lock the row. It will allow one thing to happen. So it will, like, let's say there was now they tracked for like microseconds, and they found that there's like some, let's say, 10 microsecond difference. The operation that was first there at like 0th microsecond, that starts to update the password and it locks down that particular row, the next operation, which like the first operation was 1 2 3 4, the next operation was to change it to ABCD, and the 1 2 3 4 it tries to update the password to 1 2 3 4. Let's say it takes, for some reason it takes 1 second. After that it will let go of the lock. It will say the lock is now, you can think of it as the lock is now open, and it will pass the lock to the next operation, which is to update the password to ABCD. When that tries to update the password, it will lock that row. No other changes are allowed. Okay. uh, and once that is done, the lock is open, and now whoever wants to read it, okay, so now the website Chrome in this case wants to read what is the new password, because it wants me to log in again, and then it will be allowed. Another way to think of it is that two operations, it doesn't have to be the same operation. So at one place I'm in, from one system I'm trying to update my name, from another my password, and it's going to happen in this on the same row. Okay, the way GitHub has stored it, it has saved my name and my password in the same row in the table. And again, concrete operations, there's like a milliseconds difference. One operation happens and it has locked it till this operation is complete. Once that is complete, it gives it to the next one, and the second one continues with whatever it has to change. Now, the challenges that occur with locks, one of the major one is deadlock. And this is the case where thing happened at exact millisecond, exact microsecond. Okay. Or for some reason, the row was locked. Okay. Because I was trying to update the password, and somehow there was a CPU failure, there was a process failure, and the lock never opened. So every other operation, every next operation is now waiting in a queue for the lock to open, but it's just not opening. Okay, so you are in a situation of a deadlock. Okay, so that is one of the problems that could exist. So you have, whenever you implement locks, you have to be very careful with that. The next one is any performance issues. This that might happen because, well, 10 different things. Like I, for some reason, somehow, I ended up doing like 100 different things: creating a repository, deleting a repository, updating my name, updating my password, updating my payment info, whatever else that you can do on GitHub, forking a repo, uh, starring a repo. All of this is happening, and for some reason, GitHub had decided that all of this would be on a single database, in a single table. Okay, so there's a big table with my name, with an ID, my name, my password, my like the number of repos that I have forked, the number of repos that I have existed, or something like. Just get an idea. Okay, for some reason, there it is there. A hypothetical scenario, very hypothetical. So one of the process was updating the password. It tried to update the password, and the next process is now waiting in line because the row is locked, and somehow this process fails internally and it does not give up the lock. Okay, so in that case, uh, I'm here waiting as a user that why am I, like, I'm clicking on star this repo, why is it not working, why is it not working? Because, well, performance issues right now. Okay, because there's a deadlock right there. So those are the problems that could happen. Now, I found a very good article about lock handling, or SQLite lock handling specifically, on this docs.oracle, which I would suggest you all to read whenever you get time. Uh, Now, in SQLite, you don't exactly lock a row. You lock, the SQLite actually locks the entire database. Okay, when a transaction is happening. So SQLite, it supports multiple readers, so multiple people or multiple operations can read from the database simultaneously, but only one can write to the database at a time. Okay, so that is something to remember. uh, okay, and one other thing that I would like to point is, so in SQLite the transactions, uh, they have this, like, you have a begin, which is like begins the transaction, locks the entire database for reading. And uh, so whenever you use this syntax, you're basically saying that I only want to read from the database. And there is a begin immediate, there is a begin exclusive, and you can read all about it in the link that I gave you. uh, there's also the official documentation. Mm, where was the link to it? Also, a few things have changed between version 2 and version 3 of SQLite. Just putting it out there. So there we go. Locking. Looking at the time, I think we might run short of some time. So what I will do is I will hurry up. So this is the module locks, and description implements will replicate what SQLite does, which is table level locking with queuing to prevent concurrent modifications. Okay, so const locks is a new map. Okay, we are using a map so to track the table locks and the queues. I'll write the description later. Now this is going to be a asynchronous function. Okay, export async function lock table, and it takes in a table name. If not locks dot has the table name. So locks is a map. So if it does not have this particular table name in it, which basically means that no lock exists for the table, then in that case we want to create one. We can do like locks dot set the table name, and the value is going to be an empty array, and then we'll do a immediate return so that we get the lock immediately. So the table kind of is locked immediately, and then we would do a return new promise. And if you remember, promise has two things. There is either a resolve or a reject. uh, yeah, resolve or a reject. So in our case, uh, when the lock exists, we add a new promise to the queue, and we'll say locks dot get the table name and dot push resolve. Okay, and another thing that we want to create is unlock table. So export function unlock table. This one taken the table name as well. Const q equals lock locks dot get. Uh, so what do we want to get back from it? We want to get the table name. Okay, so if not q, or queue dot length is 0, that means that there are no pending operations. uh, so the like when we use it, that will make more sense. uh, if there are no pending operations, so we are saying that whenever you are doing a write operation on the table, you would add a lock. If you are doing like 5 write operations, like 5 insert intos, so you have like there are 5 things in the queue. So when you reach the point that there is no more operation to perform in the queue, or there's like the queue length is 0, in that case we will say locks dot delete the table name. So from the map, okay, so think of a map as, you can think of it as a dictionary, okay. So I would say it is a dictionary in a way. So dictionary, and there is this particular key that we have added, which is called as table name, and we are saying that if this key exists in the map, that means operations like lock this table, okay. So step one is to lock the table. You take in which table to lock, and it has locked it by adding this particular key and no value, uh empty array. Like empty array, you can think of it as like how many operations are in the queue, so that is like empty. And to unlock the table, we are seeing that how many operations are still in the queue, uh, how many operations are in the array, you can say. And if there are nothing, then delete it from the queue, okay. Delete the table name from the locks table, uh, from the locks map, from the locks dictionary, however you want, locks map, okay. Which means that the table is now free and open, and we can say const next is queue dot shift. So this is for resolving the next operation in the queue, and then we will do run next function, so calling the next, so that the next operation can acquire the lock. And finally, the last one is export async function perform with lock, which takes in the table name and the callback, and it would go like await lock table with the table name. So we'll do the operations with perform with lock, okay, which will first go like uh, wait for the table to get locked. So in our case, let's say users table, okay, users table gets locked, so this is like waiting to acquire the lock. Then we'll do a try catch. Now in the try, inside the try, we will say await callback, which means that the first operation is done, uh, and now move to the second operation. So await the uh, okay, I wouldn't say exactly that, but let's say we are waiting for something to happen, okay, and try. And actually we don't want to catch anything, we can just do a finally, okay. And finally means regardless of anything that happens. You remember the problem, like what if my process fails and then my table remains unlocked? So the finally, so there's a try, there's a catch for error, and finally is to ensure that regardless of whatever happens, just do the next step, okay. So that is what we are going for, and we can test it, but I see I only have like 4 minutes to actually test it, and the test for this is going to be very long. So I think I'm going to pause it at this moment. uh, the way we would test it is we will actually write, uh, we'll write a lock table, and we'll write unlock table. We'll write a lock and perform an operation, okay. So perform with lock, where we will say that lock the table users, and then uh, just print out some stuff inside it. Okay. And what else? We'll try to lock a table, try to throw an error. It should still unlock the table. Uh, yeah, I think that should be good enough. We can also like lock a table. We can log some data, some like, print out some stuff. We'll add time. We can add timeouts there to actually try and yeah, like simulate a long running operation, like let's say a timeout of 5 minutes. Then it will wait till then it will print out, okay, this is done, and then you resolve. Okay, promise is resolved and stuff like that. Mm, yeah, I think that would be good. So yeah, any questions, anyone, before we end this session? I think lock is one of the things which is like a bit dicey. Oh, looking at it, there is a 1 hour gap between end of my session and the next session. uh but still, I think it's too late to actually put our mind to it. uh Anyways, I think this was good enough, and if you have any questions, feel free to remember them, and then we can talk about it tomorrow. The locks one, I will push it later, so that like it add some comments and stuff here and there, so that it's much more easy. I'll push it probably tomorrow, so you can wait on it till tomorrow. And I have, like I say tomorrow, but depending on the time zone, I have another session on 8th of December from 6 a.m. ET to 8 a.m. ET, or you can also say 11 a.m. GMT, or not sure what it would be, 11 plus 5:30 p.m. IST, I guess. No, 4:30 p.m. IST. Yeah, yeah, 4:30 p.m. IST. Okay, so I have another and final session where we'll actually push this to NPM, try and complete some homework stuff that we had, and depending on the time that we have, also we have to add joins to this. Okay, which is very important, which is something that I'm looking forward to. Add aggregate functions, so like the sum, count, average. These are also some of the things that are kind of important or necessary in database, so I'll add those as well. uh, yeah, basically a ton of stuff left to do. But anyways, I think this was a good one. Thank you so much everyone for joining. Hopefully you have a good break before the next session by Cecilia about sticker base 2.0 part 3. Okay, so you have 1 hour break, and then you can come back on stream and join Cecilia for the next session. Okay, cheers everyone, thank you so much, and see you later in the fourth and final session. Bye bye.